So we're about to start page 605 in the workbook, where we're going to be talking about differential equations. We did a little talking about differential equations about a month ago, maybe, when we were thinking about antiderivatives. And that's what we're going to start off with this day of notes talking about, is how to solve differential equations using antiderivatives. So let's take a look at what we've got in the notes. All right, so a differential equation is just an equation about functions that is dealing with derivatives. Okay, in this case, for instance, we say that the derivative of y with respect to x is this function. And so we want to find the function y in terms of x that satisfies, that has this derivative, and also has this, which we call an initial value condition. Yeah, I don't love calling this an initial value condition. Initial value conditions is usually talking about what f of 0 equals, and this is talking about f of -1. But yeah, I think I'll still call it an initial value condition. So in order to find the function that satisfies both of these conditions, the first thing I want to do is I want to think about the antiderivative of 6x squared plus 6x plus 2. And so we know that y has got to be equal to, well, what's the antiderivative of 6x squared? Well, it's going to be x cubed, and 3 times 2 would be 6. So that is the antiderivative of 6x squared. The antiderivative of 6x is x squared, and it would have to be 3x squared. So 2 times 3 is 6, and then x squared becomes x to the 1. And the antiderivative of 2 is just 2x. And remember, when we talked about antiderivatives, we knew that there was some constant value that we couldn't necessarily figure out what it was. So we needed to do this to talk about, for any real number, this is a function that has this as its derivative. But we've got an extra case here that we know that f of -1 is equal to 2. So this is our x value, and this is our y value. So what we're going to do is we're going to substitute that into this equation, and then we'll be able to solve for c. So 2 is equal to 2 times -1 cubed plus 3 times -1 squared plus 2 times -1 plus c. All right, so -1 cubed is -1. -1 squared is +1. -2 plus c. All right, so -2 plus 3 is +1, minus 2 is -1. So 2 is equal to -1 plus c. We add 1 to both sides of the equation, and c equals 3. So therefore, the function that satisfies this equation, they're kind of combining their notations here, which I don't love. We've got y equals x over here, and we've got f of something over there. But 2x cubed plus 3x squared plus 2x plus 3. So this satisfies both of our conditions. It satisfies this differential equation, and it satisfies this initial value condition. All right. When you get to college, depending on your major, especially if you major in physics or a lot of engineering fields, you'll take a whole class on differential equations and solving a whole bunch of them. In this class, where we're just starting off talking about differential equations, we're only going to be able to solve a really small number of them. We're just going to talk about one extra strategy in addition to the one that I just showed you there, which is finding the antiderivative. And we'll cover that one in the next video.